Hello there! I'm honestly really thrilled to have completed this four-part educational series on Bluetooth speaker, and now that we've reached the fifth and final episode, it's time to wrap everything up. The reason I started this series was simple. A speaker I had bought a few years ago suddenly stopped charging and wouldn't play sound anymore. Up until that moment, I had never really cared what was inside the speaker or how it worked. But when I opened it up, I discovered a fascinating world hidden behind that simple exterior. A world full of technical details, smart design, and even potential hazards. In this episode, I'm going to review the main components of the speaker, take a look at the difference between older and newer generation of speaker, talk about the future of speaker and the impact of artificial intelligence, share hidden details and interesting facts, and most importantly, cover safety tips that are often overlooked. You might hear more things about speaker in this part that you've never even thought about before. Now, let's dive into the first section, reviewing the main components. Through this series, we progressed step by step. In the first episode, we started from the outside. We looked at what components were inside and how it works overall. In the second episode, we focused on the main board, examining the control circuit, Bluetooth, charger module, and protective components. In the third episode, we opened up the speaker unit itself and talked about the dynamic driver, magnetic structure, and diaphragm. In the fourth episode, we examined the lithium-ion battery and its protection circuit, PCM, and we saw how it functions. If you haven't seen those episodes yet, their links are in the description. Make sure to check them out. Now, questions. Yeah. So, where did these small Bluetooth speakers come from? The portable Bluetooth speaker we know today are the result of the gradual evolution of AD and portability technologies. Let's go step by step. Early portable speakers. The earliest portable speakers were mechanical gramophones with horns, built in the 9th and early 20th centuries. These devices used purely mechanical drivers, no electricity, and worked with record players. What were their features? Completely manual, no batteries or electricity, and suitable only for small spaces. In 1970s to 1980s, the rise of boomboxes came. First electric portable speakers. Boombox, for example, Sony GFS 700 models combined radio, cassette players, and built-in speakers, becoming the first electric portable speakers. They ran on batteries or electricity and had simple drivers. What were their features? Portable with a handle, store sound, but heavy and limited in audio quality. How are they connected to today? Boombox laid the foundation for the idea of portable speakers, but they lacked Bluetooth and used wired connections. In 1990s to 2000s, miniaturization and digital transition. With the advent of the Walkman and Discman, smaller speakers, for example Sony SRS series, were introduced. These were still wired but battery powered and light. Features of this era: smaller drivers, low power consumption, and use with personal devices. In 2000s, right here, the introduction of Bluetooth and wireless speakers. With the introduction of Bluetooth in 2000 year and models like the Jabra SP200 in 2008, portable wireless speakers were born. This used small drivers, Bluetooth boards, and rechargeable batteries. The features wireless connection to phones, better sound quality, and compact design. How did they advance? This was the true starting point for today's Bluetooth speakers. In 2010s, popularity and improvement. Models like GBL Flip in 2012 and UE Boom in 2015 came with water resistance, 360 degree sound, and long battery life. Bluetooth 4 improved quality. Features: attractive design, high durability, and multi-device connectivity. The goal was loud and clear sound for outdoor and personal use. In 2020 to 2025, smart and advanced speakers come. Speakers with Bluetooth 5, advanced codecs such as aptX, and artificial intelligence for sound tuning hit the market. Features are studio quality sound, more than 20 hours of battery life, and interaction with voice assistant. Where are we now? The main goal remains producing loud, high quality sound for personal or group use in various settings. Now it's time for comparison. To compare, we can explore several aspects that reflect the evolution of technology in these devices. Here is a breakdown of the key differences, focusing on technical and electrical aspects, from older speakers to modern Bluetooth ones. At the first, we have power source and electricity. Okay? At the first, we have gramophones. Entirely mechanical, requiring no electricity and powered by hand cranks or springs. Then we have boomboxes. Use nickel cadmium batteries or AC power. Low voltage, typically 6 and 12 volts, and high energy consumption. But today, we have lithium-ion batteries with 3.7 and 7.4 volts, better efficiency and optimized consumption. Some models support fast charging, for example, 5 volt 3 ampere via USB-C. The next one is drivers and ID technology. At the first, we have again gramophones, simple mechanical horns with electricity, and narrow frequency range, 20 to 5000 Hz. The next one is boombox, basic electrodynamic driver with one or two drivers, woofer and simple tweeter, 5 to 20 watts output and low quality. And today we have advanced drivers with lightweight materials, for example rubber or neodymium, 2 and 4 drivers, woofer, tweeter, mid-range, 20 to 50 watts or more, and support for Dolby Atoms or 660-degree sound. The next one is connectivity and signal transmission. Yes, at the first gramophones, direct mechanical connection to the record. Boombox, wired inputs, for example IX, cassette, AM or FM radio, but no wireless. And today we have Bluetooth 5 or 5.1 with advanced codecs such as SBC, AAC, aptX HD, Wi-Fi in smart models, and multi-point connectivity. Then we have amplifier and signal processing. At the first, we have gramophones. No amplifier, sound was only mechanically amplified by the horn. Boombox, simple analog amplifiers with high noise, no digital processing. Then we came to today. Digital amplifiers class D with high efficiency, 80 to 90% digital signal processing for automatic sound tuning and noise reduction. The next one is weight and electrical design. At the first gramophone, heavy 5 to 10 kg due to wooden and mechanical materials. Boom boxes between 3 and 7 kg due to large batteries and plastic bodies. And today between 0.5 to 2 kg thanks to lithium batteries and lightweight materials like aluminum and durable plastic. The next one is durability and electrical safety safety. Gramophones, no need for electrical durability, only mechanical. Boombox, no water or dust resistant standard, risk of nickel cadmium battery leakage. And today we have IPX4 to IP67 standard water and dust resistance battery management systems to prevent overcharging or overheating. The next one is energy consumption and efficiency. At the first gramophone, no electrical consumption. Boombox, low efficiency between 3 30 to 50% due to analog amplifiers and nickel-cadmium batteries. And today, over 80 to 90% efficiency with Class D amplifiers and optimized battery consumption, energy-saving modes. And lastly, we have artificial intelligence and advanced electronics. In old ones, I mean gramophone and boombox, we doesn't have intelligent processing. But today, smart chips for automatic sound tuning, integration with voice assistants, and software updates via apps. For summary, speakers have evolved from electricity free mechanical gramophones to heavy boombox with nickel cadmium batteries and wired connections, and now to lightweight Bluetooth speaker with lithium ion batteries, multiple drivers, and artificial intelligence. In other words, we've gone from a mechanical horn to a smart box that understands what we want to hear. We've reached artificial intelligence. Yeah, as you can see it. Artificial intelligence, I mean AI, has had profound impacts on the development and performance of portable Bluetooth speakers, transforming these devices from simple music playback tools into smart multi-purpose gadgets. The key impacts of AI on speakers include these. Okay, at the first we have improved voice interaction with smart assistants. And we have speech recognition and processing. AI using speech recognition technologies, natural language processing, NLP algorithms, and deep learning enables accurate detection of voice commands. Okay, for example, speakers like Amazon Echo Dot or Apple HomePod Mini with Alexa and Siri can execute complex commands like play a relaxing playlist or turn off the room's light even in noisy environments. The next one is multilingual support. AI allows speakers to recognize and support various accents and language, which is highly beneficial for non-English speaking users. The next one is personalization of user experience. The first one is learning user behavior. AI analyzes user behaviors such as music preferences or usage timing and provides personalized recommendations. For example, Alexa can suggest a playlist based on listening history. And the next one, automated routines. Users can define command sets for a specific situation. For instance, saying good morning can prompt the speaker to play music, open curtains, and read the news. Saying good night can make the speaker turn off lights, lock the door, and set the morning alarm. The next one is integration of Bluetooth speaker with voice assistants. At the first, modern portable Bluetooth speakers leverage AI to integrate with voice assistants. This integration enables voice control of devices and interaction with smart home ecosystems. We have some key features. At the first, touch-free voice control. Users can use simple voice commands like play my favorite playlist or turn up the music to play music, adjust volume, or control other smart home devices. This is especially practical for portable speakers used during travel or outdoors. The next one is multi-room connectivity. AI-enabled speakers can integrate with other compatible devices in a wireless network to play music simultaneously in multiple rooms. For example, Sonos Era enables the creation of a multi-room ID system. The next one is sound quality optimization. At the first, we have automatic sound adjustment. AI analyzes the environment, for example, room size or noise level, to automatically adjust sound quality for the best ID experience. The next one is support for advanced ID technologies. Some models support technologies like TWS through wireless stereo to connect to speakers for stereo sound. And the next one is enhanced portability and durability. Here we have smart energy management. AI optimizes battery consumption to extend speaker battery life typically between 6 to 10 hours. And durable design. AI helps manufacturers analyze environmental data to design a speaker with standards like IP67, water and dust resistance. The next one, and lastly, we have practical and engaging applications. At the first, we have interaction with other AI systems. Some speakers are compatible with Google Assistant or other assistants and can serve as smart home control hubs. These speakers can perform tasks like checking the weather, reading news, or booking restaurants. The next one is smart home integration. AI has turned Bluetooth speakers into smart home control hubs. Users can control all aspects of smart home, such as Philips Hue lights, Nest thermostat, or smart locks, via voice commands. For example, Sonos Room with Alexa can manage multiple devices simultaneously. The next one is entertainment and education. Users can use speakers for playing podcasts, audiobook, or even cooking tutorials. And lastly, we have commercial applications, as you can see here. In work environments, smart speakers can be used for meeting, management, setting reminders, or automatically routing customer support tickets. So, now we have some challenge and limitation, as you can see. Challenge, limitation. Okay, at the first, privacy. AI collects user data to process voice commands, raising concerns about privacy. The next one is internet dependency. Many AI features in speaker rely on an internet connection, creating limitation in environments without Wi-Fi. The next one is feature with AI. Emotion recognition at the first. In the future, AI might detect a user's mood through voice tone and play suitable music. Next one is integration with smart cities. Speakers could integrate with smart city infrastructure such as for public announcements or traffic management. And lastly, we have greater independence. AI advancements may make speakers independent of internet relays, processing voice commands locally. And we have some notable brands and models and some recommendation for choosing a speaker. At the first, pay attention to battery life at least 6 and 10 hours, sound quality, and weight under 1 kilogram for easy portability. And models with IP67 standards and TWS support are better suited for outdoor use and stereo sound. So, what future awaits us and our speakers? Yes, you can see it. The future of speakers look incredibly exciting given technological advancements. Beyond AI, which has already added a whole new dimension to speakers, here are some ideas and trends for the future of speakers. At the first, wearable and flexible speakers. Imagine speakers in the form of smart fabrics or flexible gadgets that can be attached to clothes, backpacks, or even your skin. The speakers could be ultra light and portable, offering excellent sound quality using nanomaterials. For example, a jacket with built-in speaker that plays music and is waterproof. The next one is solar and environmental energy charging. Speakers that charge with ultra thin solar panels or energy harvesting technologies such as body heat, vibration, or radio waves will become common in the future. This means no need for batteries or charging cables, allowing your speaker to work in nature or anywhere. The next one is holographic speakers with advanced display. Speakers with holographic displays or projection capabilities could show 3D image, visual information, or interactive interference in the air. For instance, while playing music, a visual representation of the song or virtual assistant chatting with you could appear in front of you. And the next one is mobile and robotic speakers, as you can see here. Speakers that follow you like small robots, for example, a spherical speaker with sensor and small wheels that moves around the house with you, always delivering sound optimally. Or even flying speakers like tiny drones that follow you in the air while playing music. The next one is native materials and adaptive sound quality. In the future, speakers might be made from materials like graphene, producing exceptional sound quality in very small size. Additionally, speakers could use environmental sensors to adapt to their surroundings. For example, focusing sound on you in crowded room or optimizing sound disappearing outdoors. The next one is biotech speakers. Another idea is speaker integrated with the human body or the environment. For instance, speakers powered by bioenergy, like body heat, or made from synthetic tissues that feel more natural. And lastly, we have biometric personalized sound. Future speakers might analyze brain waves or heart rates to play music tailored to your emotional and physical state. For example, suggesting claiming song when you are stressed or singing the rhythm to your heartbeat. Overall, future speakers will not just be sound playing devices, but multifunctional, mobile, environmentally adaptive gadgets that could even become part of our clothing or bodies. If a speaker can walk, maybe it could dance with you or even make coffee. So, when we look at a speaker, we only see its sleek appearance and loud sound, but behind this simple exterior lies a complex world of electronics that shapes the true quality of the sound. Now it's time to play the fact shot cards game together. Our topic is hidden truths about the electrical structure of speakers. I will mention some features, then pause for a moment, take your time to guess which fact I am referring to, and feel free to write your guess in the comment section. Now we will start. At the first, a speaker impedance, apparent electrical resistance, is not fixed and changes with the frequency of the ID signal. For example, a speaker with a nominal 8 ohm impedance might drop to 4 ohms or lower at specific frequencies, like resonance points. This can strain the amplifier and must be considered when designing an ID system. What is that? Yes, frequency dependent impedance. The next one. Here we have when the speaker's diaphragm moves, the voice coil moves in a magnetic field, generating an induced electrical current. This current can interfere with the main signal, causing distortion. High quality amplifiers must be able to manage this effect. What is that? Yes, electromotive force. Now we came to the next one. Okay, we have the crossover circuit not only divides frequencies between different drivers, for example woofer and tweeter, but can also alter the system overall impedance. A poorly designed crossover can degrade sound quality or even damage drivers. What will that? Yes, role of the crossover in energy management. The next one. So, during prolonged use, the voice coil heats up, increasing its electrical resistance due to copper's positive temperature coefficient. This can reduce output power and alter the frequency response, a detail I've overlooked in simple design. What is that? Yes, voice coil temperature effect. And the next one is the quality and type of magnet used, for example, neodymium or ferrite, affect the speaker's response. Weaker magnets reduce sensitivity and cause more distortion, but these details are rarely mentioned in technical specifications. What is that? Yes, impact of magnetic materials. And lastly, we have Kelp's connections, and even the internal layout of speaker can cause electrical interference. For example, RF noise. This is more pronounced in wireless or Bluetooth speakers, which contains more electronic components. And what is that? Yes, effect of electrical interference. So, for summary, this part. The electrical structure of speakers is far more complex than it appears, with factors like back EMF, impedance variation, and component quality significantly impacting performance. Diverse design often stem from cost cutting, leading to distortion, reduced speaker lifespan, or incompatibility with amplifiers. Now I will answer three questions that might be on my mind and perhaps yours too. At the first, why do some speakers have two drivers? So, for answer to this question, frequency diversion between woofer and tweeter. Speakers with two drivers typically have a woofer for low frequencies like bass and a tweeter for high frequencies like treble. This design allows each driver to focus on a specific frequency range, improving sound quality as a single driver cannot reproduce all frequencies with high fidelity. The next one is increased ID precision. Dividing tasks between two drivers reduces distortion and enhances sound time. The next one is a wider frequency response. Two drivers enable the speaker to cover a broader frequency range, for example 20 Hz to 20 kHz, which is harder for single driver speakers. And lastly, improved power output. Having two drivers can increase sound output power as each driver handles its specialist task, putting less strain on the system. The next question is, what is the role of heatsinks and internal ventilation in large speakers? So for answer this question, we have these answers. At the first, managing voice call heat. In the larger speakers, especially woofers, the voice call gets very hot during loud or prolonged playback. Heat sinks and ventilation ports help dissipate this heat, preventing coil burnout and maintaining sound quality. The next reason is extending speaker lifespan. Without proper ventilation, excessive heat can damage internal components and shorten the speaker's life. Aluminum or copper heatsinks in professional speakers distribute heat more effectively. The next reason is performance stability at high power. In large speakers, for example, concert subwoofers or home theater systems, internal ventilation like ports or small fans ensures stability during heavy use, such as playing powerful bass. And lastly, we have reducing thermal distortion. Excessive heat can alter the coil's resistance, causing added distortion. Proper ventilation minimizes this issue. And the next question is, what are the differences in circuit design between basic and advanced models? So we have a bigger card here, as you can see. At the first, crossover component quality. In basic models or basic design, uses low quality capacitors and inductors. For example, cheap electrolytic capacitors, leading to signal loss, noise, or distortion. The crossover circuit is simple and may not divide frequencies accurately. In advanced models, as you can see here, we have high quality. Uses polypropylene film capacitor, high quality air core inductors, and precise resistors. These components reduce distortion and provide a more accurate frequency response. The next one is crossover circuit design. In basic design, typically uses signal stage crossover with a gentle slope, 6 dB per octave, causing frequency overlap and reduces sound clarity. But in advanced models, we have used multi-stage crossovers with steeper slopes, 12 or 18 decibel per octave, offering precise frequency division and protecting drivers from harmful frequencies. The next one is impedance management. In basic design, the speaker's impedance may not be properly matched with the amplifier, stressing the amplifier or causing power loss. But in advanced design, circuit design with more stable impedance compatible with various amplifiers, delivering better performance in different conditions. So, we came to the internal connection. In basic design, uses thin caps and poor soldering, leading to signal loss or noise. But in advanced models, we have uses high quality caps, for example, oxygen-free copper and robust connections, offering lower resistance and cleaner signal transmission. And lastly, we have electrical protection. So, in basic design, we have typically lacks protective circuits, for example, fuses or current limits, and increasing the risk of coil burnout. But in advanced models, as you can see here, includes advanced protective circuits to prevent overload or excessive signals. For summary, these parts, as I can show to you and show this to you, yes. Speakers with two drivers are designed for better frequency, coverage, and higher quality. Heat sinks, as you can see here. Heat sinks and ventilation in large speakers are critical for heat management and extending device lifespan. And professional models use higher quality components and more complex design, while basic models often sacrifice quality to cut costs. Now we reached the section worst possible design in speakers. Here I will read the first part of a sentence, pause, and ask you to guess which part of the speaker this flow relates to. Then I will reveal the answer and dive into the technical explanation. At the first, we have poor or inappropriate what? Yes, crossover. Using cheap components, for example, substandard capacitors or incorrect crossover design can cause frequency overlap, distortion, or even driver burnout. For example, if low frequencies are sent to the tweeter, it will quickly get damaged. Secondly, we have impedance mismatch with, yes, amplifier. Designing a speaker with very low impedance, for example 2 ohms, without considering the amplifier's capability can cause the amplifier to overheat or shut down. This is common in cheaper systems. And now we have non-standard what? Yes, cabinets. A poorly designed cabinet, for example, with thin walls or no internal sound insulation, causes unwanted resonance, vibration, and added distortion. The worst case is when the cabinet amplifies specific frequencies, disrupting sound balance. The next one is inadequate. What? The answer is here. Voice coil. A voice coil that's too small or made of low quality material, for example, poor grade aluminum instead of copper, reduces heat tolerance and causes excessive distortion. The next one, which neglecting thermal what? Ventilation. Yes, the answer is here. I don't know how it happens. Okay, speakers with poor design for dissipating voice coil overheat during prolonged use, shortening their lifespan. The worst scenario is when there are no cooling vents at all. And the next one, incorrect driver. Yes, placements. That's correct. If the woofer, mid-range, and tweeter are not properly positioned on the cabinet, for example, too close together or without considering sound phase, sound waves interfere, degrading audio quality. And lastly, we have using weak. Yes, all of us know it is magnets. Low quality or undersized ferrite magnets reduce speaker sensitivity and demand more power from the amplifier. Now, let's review speaker safety types and we came to, yes, safety types. At the first, we have preventing short circuits. Always ensure speaker cabs are properly connected and insulated. A short circuit can damage the amplifier or speaker. The next one is impedance matching. The speaker's impedance should match the amplifier. For example, 8 ohm speaker with an 8 ohm amplifier. Too loud an impedance can overheat the amplifier. The next one is protecting against heat. Avoid placing speakers in very hot or humid environments as heat and moisture can damage the voice coil and internal components. The next one is proper voltage. If you have an active speaker, with a built-in amplifier, use a power source with the correct voltage and current to avoid damaging circuits. And lastly, we have avoiding ID shock. Sudden high volume signals, for example, turning on the amplifier at high volume, can damage drivers. Always start with low volume. Alright friends, we've reached the final part of this video. In this section, we tried to unveil the secrets of speakers and get to know them closely. Now, before we say goodbye, let's get a bit dreamy and share our wishes. What kind of a speaker would you love to have? Personally, I want a speaker that's like a true friend, one that understands me, my emotions. When I'm feeling overwhelmed, it sends it, gets me, and play a song to lift my mood, or even dance with me and make life for me more beautiful. What about you? What's your dream speaker? Let us know in the comments. Farewell!